All right, welcome everyone to our beginning of our study of logarithms and exponential functions. We are going to start off today with a first of three parts of a video. We're going to look first today at this video as what is an exponential function. We're going to answer that question very quickly in the idea that a function or an exponential function is in the form y equals a times b to the x. A and b are just numbers that will be replaced later on, and x is our variable. Notice that this is going to be different than any other type of function we've ever dealt with before, as x is in the exponent and not in multiplication as we would normally have in a polynomial. So a few notes that we need to really pay attention to. We are not allowed to let a equal to 0, because if we did, we'd have 0 times something, and that's always 0. It's not interesting. B has to be bigger than 0. It can be a fraction. It can be bigger than 1, but it cannot equal 1. If b was equal to 1, then we would just have a times 1. Well, that would just be a number, and that's a horizontal line, and that is not interesting either. So those are the first three little notes that you have to pay attention to. The second is one I already mentioned. You notice that x is in the exponent, and it only belongs to the value of b. An example there would be something along the lines of 3 times 2 to the x. That exponent only belongs to the 2 and not to the 3. Need to make note of that, as that is very important, as we noticed with our study of our exponent rules in previous discussion. When we talk about an exponential function, we say a is called the initial value. It's what happens essentially at the beginning when we deal with more real-world problems. It is, you can make a note of this, this is our Y-intercept. So it's also called the Y-intercept. It's when x is 0, because b to the 0 power is 1, and we get the value of a. Something I forgot to write down here is that b is the base. B is called the base of the exponential function. So this would be base b. When b is bigger than 1, the function represents a growth model, or just a growth. It is growing as time goes on if we deal with real-world stuff. Basically, this says as x increases, y increases. B is called the growth factor in this case, specifically. And when b is between 0 and 1, like a decimal or a fraction that is between 0 and 1, the function represents a decay, and basically says as x increases, y decreases. And likewise, in these particular equations or functions, b is called the decay factor. All right, these are very important pieces of the basics of an exponential function, which is what I really want to get across in this short video. And just a couple of examples that we can look at here. So hopefully we can start looking at exponential functions and just looking at them and knowing right away very quickly if the function is a decay, a growth, what's the initial value, and what's the decay factor. That's the type of idea we want to look at. So we have the function y equals 3 times 2 to the x. And you just have to make a note. Is it a growth or decay? And really you're looking at b. So b is equal to 2 in this case. So this is base 2. So since 2 is bigger than 1, that means it's a growth. We'll just do it this way. It's a growth. The growth factor is 2. And I want to make a note here as we continue. This means it's doubling. The function is doubling as x gets bigger. And the initial value is 3, as that's the value of a, or it's when x is equal to 0. All right, it really is as simple as that when you just look at the equation. So what is the next example here? If we had y equals 1/2 to the power of x. Well, this is the exponent on top of 1/2. That means the function is a decay because 1/2 is greater than 0 but less than 1. It's between 0 and 1. It's not a growth factor, so the decay factor is that value of b, which is 1/2. And the initial value is the a. Well, since a can't be 0, that means a here is 1. I want you to be able to look at these equations that quickly and determine what type and all the pieces of your functions. All right, so here we go. We have y equals 1/3 times 4/3 to the power of x. Now, I want to first point out, what is the initial condition? Well, the initial condition is, or the initial value is 1/3. That's pretty easy. That's the number in front of the thing with the exponent, or the number with the exponent. Then we need to determine, is it a growth or a decay? Well, sometimes people look at this and go, well, it's a fraction, therefore it's a decay. However, b is equal to 4/3 here, but 4/3 is bigger than 1, and that means it's not a decay, but a growth. So the growth factor in this case is 4/3. All right, 2 more real-world looking problems where we deal with decimals, which turned out to be percents, as you'll see in the next video, or in the third video, actually. And in this particular case, we have y equals 2.7 times 1.034 to the power of x. I know that this number right here is bigger than 1. That is very easy to see. That, therefore, it is a growth function. That growth factor is 1.034, and the initial value is 2.7. One more simple example. And, oops. We had y equals whatever the first number was times 0.94 to the power of x. This is a decay. The decay factor is 0.94, and the initial is 2. I know that wasn't a 2 there on the last problem, but you know that the initial value is that number in front. Not sure what happened to my presentation. It wouldn't let me go back. So there's the last example. Make sure you watch the next video up here, part 2. And hope you learned a little bit, and I will see you guys later.